Hello, today I'm going to finish off this higher tier calculator paper. It is from November 2015, questions 16 to 25. So let's get started. Okay, we start with question 16, part A. Write 640 million in standard form. Okay, standard form. Just put this down a minute. A times 10 to the n, say. Now A must be greater or equal to 1, and it's got to be less than 10. So what we need is 6.4 times 10 to the, we'll have a look. I always count them back from here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1 mark for that. Part B, work out 3 times 10 to the 7 divided by 6 times 10 to the 4. So I'm going to give you your answer in standard form, of course. So let's have a look. I'm going to slightly rewrite that as this. I'm going to take 110 off there and put it there. So that's going to be 30 times 10 to the 6. 6 times 10 to the 4. We can cancel that down into there. 6 into 30, 5 times. So we end up with 5 times 10 to the rule here is we'll subtract these. 6 minus 4, 2. Okay. That's that one done. Question 17. L1 and L2 are parallel lines. The equation of L1 is y equals 3x plus 2. L2 passes through the point 3, 4. Find an equation for L2. Okay, they're parallel lines, so the gradient is the same. So we can write this for L2. Y will it be the same gradient, 3x. The only thing that's going to change is the intercept. I'm going to call that plus c for now. And we've got the values for x and y. The point they go through, so we can write 4 equals 3 times 3 plus c. That's going to be 9. Take the 9 this side. 4 minus 9 is going to be minus 5. Let's see. Popping that back into this gives us y equals 3x minus 5. Done. Question 18. Box plot shows information about the number of countries competing in each Winter Olympic Games since 1948. Part A. Write down the median. That's all fairly straightforward. That's just this line here. And we can read that directly off as 37. Okay. And then part B, work out the interquartile range. Okay, we need to put down the lower quartile and upper quartile. The lower quartile is 35 and the upper quartile 71. So it's 71 minus 35, 36. And now we've got to do some interpretation. Let's read it first. The table below shows information about the number of countries competing in each Summer Olympic Games since 1948. So it was winter, now we're summer. And we've got to look at all this information. And we've just got to compare the two distributions. It doesn't matter too much what we put down, as long as we let the examiner know that we understand what's going on. I think we'll compare the medians first. So the median here is 121. And the first median was, what we said was 37, wasn't it? So it's clearly the median of the Summer Olympics is 3 times that of the Winter Olympics, approximately. And then we can look at lower quartile and upper quartile and see that, again, it's much greater in the Summer Olympics than the Winter one. Just put that information down in a couple of sentences. Something like this. Okay, done. Question 19. The value of P is 4.3. The value of Q is 0.4. Both P and Q are given correct to the nearest 1 decimal place. Write down the lower bound for P. Okay, looking at P, for it to be 4.3 rounded to the first decimal, the lower bound has to be 4.25. Any lower than this, and it would round down to 4.2. So that's the first part, 4.25. Now part B. We have this equation, R equals P plus the reciprocal of Q. And we have to work out the upper bound for R. Okay, for R to be at its largest, P must be at the upper bound, which is 4.35. We also need to add the largest reciprocal of Q. And as Q is less than 1, a lower value of Q will give a larger reciprocal. So we need to find the lower bound for Q, which is, using the reasoning above, 0.35. So R equals 4.35 plus 1 over 0.35, which equals 7.2071. And to finish off, we'll round this to 7.2, which is the accuracy of the original data. Done. Question 20. Here are 2 watch faces, A and B. Both watch faces are circular with radius 2 centimeters. The materials used to make both watch faces have the same thickness, so we know they're the same volume. A is made entirely of plastic. B has a 20-degree sector of metal and a 340-degree sector of plastic. The ratio of the cost per centimetre squared of the metal to the cost per centimetre squared of the plastic is 3:2. Work out the ratio of the cost of the materials for A to the cost of the materials for B. Give your answer in its simplest form, and you must show all your working. Okay. Well, this is a strange looking question. Let's have a look. Both circles are the same size. We could go into working out areas, but I think we could do it just using angles and ratio. Okay, so if this 20 degrees is metal, and it costs more than the plastic at a ratio of 3:2, which is 1.5 times more, this 20 degrees will cost the same as 30 degrees of plastic, 1.5 times more. So write something explaining that. Okay, that will do. Now, let 1 unit of cost be that of 1 degree of plastic. Total cost of face A is 360 units, and the total cost of face B is 340 units, which is the plastic, plus the 30 units, which equals 370 units. So the ratio of cost of face A to face B is 360 to 370, which simplifies to 36 to 37. And that's that. Now I will add one thing. This could have been done in a much more complicated way by working out areas and ratios and things like that. But as long as it's seen and explained, you should get all the marks. Okay, done. Question 21. 148 students went to Brighton. Each student went to the aquarium, or the Brighton Wheel, or the Royal Pavilion. The table gives information about these students. And there we have a nice table with all this information. The teacher takes a sample of 40 of these students. The sample is stratified by gender and by place visited. Work out the number of students in the sample who are female and went to the Brighton Wheel. Okay, here are the females, and here are those who went to the Brighton Wheel. And of these, we find that 35 were female. So we stratify on that number, and we use the fraction of 40 over 148, which is the total, and we multiply that by 35. And that equals 9.459. And as we want our students whole, we'll just round that down to 9. Okay, quite a simple one. Done. Question 22. Alison is using the quadratic formula to solve a quadratic equation. She substitutes values into the formula and correctly gets this lot. Work out the quadratic equation that Alison is solving. Give your answer in the form ax squared plus bx plus c equals 0, where a, b and c are integers. Okay, this is just a substitution problem. Fortunately, we're given the quadratic equation on the formula sheet. So let's get that. We can see that 2a equals 4. So a equals 4 over 2, which equals 2. Also, minus b equals minus 7. So b equals positive 7. And finally, 4ac equals 32. All we need to do is substitute a equals 2, which gives 4 times 2 times c equals 32. So c equals 32 over 8, which equals 4. Simple as that. Question 23. Part A. We have this graph of y equals sine x. It goes from minus 180 to positive 180. And we're asked to sketch the graph of y equals sine x plus 2. This one is quite straightforward. As we already have sine x plotted, all we need to do is add 2 in the positive y direction to each point. So all these zeros are going to go to positive 2. And this minus 1, we add 2, gives us positive 1. And positive 1 add 2 gives us positive 3. And then we just draw the graph. And I always label it, so we do that as well. That's part A. Now part B. Here we have cos x from minus 180 to positive 180. And now we're asked to sketch the graph of minus 2 cos x for the same region. This time we just multiply the y value of each point by minus 2. Okay, zeros times minus 2 are still 0. So we can mark these 2 points, here and here. The minus 1's multiplied by minus 2 become positive 2, here and here. And one more point, positive 1 multiplied by minus 2 becomes minus 2. So we mark that as well. All we then need to do is sketch the graph. And that's that. Done. Question 24. ABC is a triangle, and as usual the diagram is not accurately drawn. AC equals 8.4 meters. Angle ACB equals 40 degrees. The area of the triangle equals 100 meters squared. And what are we asked to do? Work out the length of AB. Give your answer correct to 3 significant figures, and you must show all your working. Okay, let's have a look. So, we need to find this length here, AB. It looks like to me we will need the cosine rule, because we have this length and this angle. But then again, we do not have this length BC. Okay, we don't have BC, so we need to find this. And that is where the area of 100 meters squared comes in. So let's get the formulas for cosine rule and area of a triangle. And first, we arrange this area equation to make BC the subject. This 2 will go up here, and this B sine C goes down here. Now we'll put in what we know. 2 times 100 over 8.4 times sine 40, which equals 37.0410435. And we'll leave that in the calculator. Now we have enough information to use the cosine rule. Looking at this, we do not need to rearrange this equation. AB is this A squared. Therefore, AB squared equals 8.4 squared plus the previous answer squared minus 2 times 8.4 times the previous answer again, times by the cosine of 40 degrees, which equals 965.89746. And then to find AB, we square root this answer, which gives 31.078. Just to finish it off, give the answer as 31.1 to 3 significant figures. Done. Last question on the paper, 25. Mamusa has 30 sweets. She has 18 fruit sweets, 7 aniseed sweets, 5 mint sweets. Mamusa is going to take at random 2 sweets. Work out the probability that the 2 sweets will not be the same type of sweet. You must show all your working. Okay, I think I'm going to draw a tree first, probability tree. So let's have a look at that. We make this one fruit. This one can be the aniseed. and this one can be the mint. Okay. Probability of taking fruit is 18 to 30. And after that it would be 17 out of 29, because we got taken one already, so and then aniseed is going to be 7 out of 30, and be 6 out of 29. This one is 5 out of 30, and it would be 4 out of 29. What I'm going to do is work out the probability that the two will be the same, and then take all of that from 1. I think that's the easier way of going about it. So this one's going to be 18, 30 times 10 over 29. Now I need the calculator. 18 over 30 times 17 over 29. 51 over 145. I'm going to do the same for all of those. I'm taking it all from 1. 1 minus, open a bracket, 51 over 145 plus okay, done. Now if you like the videos, click the like button, and if you really like them, then please subscribe. Thank you for watching.